Hey everyone. So today we're going to be doing a quick little video here about caching. So caching for AI agents doesn't have to be just for your agents, but for your workflows. What is it? Why do we use it? What are the benefits? When do you want to use it and when do you not want to use it? Because you don't always want to cache information. It depends on the type or it depends on the use case. Um, so yeah, just kind of diving into the high level aspect of caching real quick. So quick introduction, if you've never really heard of it, or maybe you've heard of it, don't really understand it, we've got an analogy. So imagine you run a coffee shop and every day the customers are asking you for the Wi-Fi password. And let's say it's a long password like X2Y4X97B22. And you don't want to have to like look that up every time because you don't remember it. So instead of looking it up each time, you just write it on a board or you have it like on a sticky note right here and you can basically just hand it to them, show it to them, that sort of thing, right? It's going to save you time and effort because that's, kind of caching basically. So let's get into it. In simple terms, it's like a shortcut to accessing your information. So rather than having to, you know, walk from the basement all the way up to the top floor to get information, you could just take the elevator. I don't know. I'm trying to make these analogies here. Anyways, it's going to store your frequently used information so that it can be accessed faster next time, right? Why is it important for AI agents? When we build these workflows in end-to-end, they often need to process lots of data. So by caching, it's going to speed up that process. It can also help save costs. If we're doing an API call, we could save the information that's frequently requested for 10 minutes. And so then if we're getting 5 requests per 10 minutes, we're not having to make that call every time. We're just pulling it in because we know that this is the input and we already know the output. So why would we use the tool to get the output again if we have the output right here? So some key points here: faster data access. By storing frequently used data closer to the processor, caching significantly reduces the time needed to retrieve information from slower storage sources like disk drives or network servers. It's going to reduce the latency, of course, because whatever the trigger is, you'll get to the output quicker with this caching process in place. Bandwidth conversation, scalability, improved user experience, and enhanced reliability. So this I pulled straight off of a website. I'm sure I linked it somewhere. There's some links in here. But for scalability, think about the fact that you're offloading the processing and you're not making as many requests, so you can handle higher amounts of requests. You can handle loads of data, and it won't slow down your performance. So an example here is, imagine you're building an AI-powered travel assistant, and it's going to help users like check flight prices, hotel information, all that kind of stuff. So if a user is asking for a price of a flight from New York to London, your agent would go, okay, it would grab New York, it would grab London, it would probably grab the dates. If it needs the dates, that's the thing, is like the inputs have to be the same in order to use that cache information, of course, otherwise it would be inaccurate. But the agent would make an API call to that service, which would take, let's say it takes 3 seconds, and let's say each call is, 10 cents. And then they finally are able to respond with an answer. Every time a user asks that same question, the AI is going to have to repeat that information. So caching is typically just kind of short-term storing this information. Short-term can be defined however you want. You could even potentially like put all of your requests into some sort of database. You could have the agent, before it actually goes out and makes a call, scan through the database and check, okay, has this request already been made? If it has been made, we have the output here. I'll throw that out. Now, when I get it later into like when you would not want to use that, if the data is going to be changing. So maybe something like flight prices, you wouldn't want to do that for like long term, because a flight in February won't always be the same as a flight in January. Or that was a horrible example. I mean, I guess if you go all the way, but you know what I mean, right? Like flight prices change. So that's an example of maybe when you wouldn't want to do it. Same thing if like you were looking up, like, what's the current price of this stock ticker? That'll almost never be the same. So that's one where you would want to do a unique call every time. But with caching, in this case, let's say, first request is stored in a cache for 10 minutes. If the user asks for that exact same, hey, I want a flight from New York to London, we could just grab that and it would take half the time. We wouldn't have to pay for it, and just improved user experience. So how does it work? There are 3 different types of caching. here's an article I linked about these three types. But you've got in-memory caching, disk caching, and distributed caching. And I wanted to link this article because, like, full transparency, this isn't something I really understand enough to be able to speak on, like the technicalities of caching. It's just more about like the principles of it and why it's useful and how to use it. So yeah, I would give that a read if you're interested in understanding the stuff with like the RAM. But how does it work in end-to-end? So you could use it. You could use a service like Redis, which is an in-memory like data structure that's commonly used for caching because it has high performance and flexibility. And so you can integrate that right into N8N. I found a post here about caching your HTTP responses with Redis and N8N from the community. You can look at that. And also I linked to Redis right here so you can learn how to use it and get some more information on it. You could also be using custom nodes or workflows. So you can use these to basically manage the data you're caching. So for example, you could have a workflow designed to check if data exists in the cache before making an API call. This cache could be, it doesn't even have to get too technical. So, technically you could have like a Google Sheet be your cache database if you wanted to. And I guess what that would look like is, when your workflows are running, you would store, here's the user request, here was our response, and you store that. And then you could, have on a trigger the rows being deleted. Like after 10 minutes that this row was added, you're going to come check, see when it was added, and then delete it after 10 minutes. Like that is a workaround. It's not the most efficient or scalable way, but that is technically like how you could cache some data. It could be an Airtable or Supabase, Postgres. But yeah, you just get creative and do something like that. Because if your logic is built in where you're going to be checking that every time, you don't want to be checking through, thousands of records. That's why the whole point is it's going to be quick. It's only going to be looking for some short-term, temporarily stored inputs and outputs. So there's also an article right here on Medium that talks about, I was going to see if it would pull up the little preview, but it talks about like optimizing this caching for agents in N8N. So that's a good one to read. And yeah, like I said, it provides a practical example of building a simple caching mechanism in N8N for your AI agents. Okay, but then like the whole topic about when to use it and when to not use it. We've got some links here. This first one is caching guidance from Microsoft. Overall, the 3 times when you would think maybe I want to cache this data here would be frequently accessed data. So if your workflow is repeatedly requesting the same exact information, obviously caching is going to help out there. If it's expensive to retrieve your data, so if your API calls are $1 every call, then maybe look into how you can cache that data so you can just cut down the calls by maybe doing 1 for every 5 rather than saving some money there. And then a high read to write ratio. So in scenarios where data is read frequently but updated infrequently, caching can improve performance by being able to return that quickly, and it's still going to be accurate. And like on the exact flip side of things, when we move down here into when not to use caching, if the data is changing rapidly, it doesn't really make sense. If you've got strict consistency requirements, so apps that require the most up-to-date data at all times, kind of similar with the rapidly changing, and then memory constraints, because it's going to have extra memory and it's going to make, your agent basically is going to do another step before it's able to get to outputting something. So if you're kind of in that environment with limited resources, then it honestly may just end up hurting the workflow and impact the performance. It could even end up like increasing the latency rather than, one of the whole points of caching is to decrease the latency. So caching pros and cons here, if you're curious. Also 7 reasons not to cache. But best practices, you can implement cache and validation, and you can monitor your performance, obviously, just to see if you need to update or adjust your strategy if it's not actually being helpful to your workflow, if it's harming the workflow. But the cache and validation is just kind of along the point of like, if the data is rapidly changing, if you have these requirements, making sure that you have like the right expiration time so that it's not increasing latency and that your information that you're sending out as the output is still going to be accurate. So yeah, we've got caching best practices from Amazon right here if you're curious. But hope that one clears up some things if you've been hearing the term caching but don't really understand it or when to use it. So thanks, guys.